Hi guys, we're starting our unit chemistry. We already went through um, a little story about the atoms, and now we're going to piece all this together. So, in the universe, everything is made up of one or two things: energy or matter. Matter is anything that has mass and volume. So, we're going to talk about the building blocks of matter. Now, when you build, something has to get bigger. So we can build things and we can take them apart and reuse them. These things are called our elements on the periodic table. So if you look at this chart, this is an organized chart that took scientists a while to figure out how to actually organize this. And it's actually organized in a specific format. Now you notice that there are colors. There's blue, purple, and there's like an orangey color. And on the top, um, if you look at the scale, if you look at the symbols, you notice that this color is nonmetals. This is like a mustard color. The blue, they say, are metals, and the purple is metalloids. So everything in the universe is either a nonmetal, a metal, or a metalloid. And then it comes together to make other things. So you're made up of nonmetals, metals, and metalloids. All things are made up of these things. So we're going to talk about um, how that helps us, how we interact with them, and what that actually means. Okay, so the elements are the smallest substances in the universe. They are the smallest substances, and what that means, it's something that we can actually work with because there are smaller subatomic particles than an element. There's smaller things than it, but these are like pure substances that pretty much manufacture our world. This builds our world. So there are 100 elements that we know of. There's more. There's probably like 118. 92 of them are natural, and the rest of them are man-made. Now, if you look on this periodic table, you'll notice there are columns and there are rows. So out of these, most of these elements, there are little symbols on them too. Most of them are solids, and they're solids at room temperature. There's 2 of them that are liquids, and there's a couple of them that are gases, a few, maybe like 7 or 8 that are gases. Elements cannot be broken down chemically or physically into anything smaller. What does that mean? That means if I took a knife and I cut the element, it's still the same thing. It's still an element. If I burn the element, it's still the element. It's still going to be an element. So I can't break it down any smaller than it actually is. This is it. It'll melt when I try to burn it. It's not going to break apart. So, like when you burn paper, you don't have paper anymore. Now you have ashes. You can't have paper. But if I burnt gold, I'm not going to be able to burn it. It's just going to melt into liquid gold. I'm never going to be able to get something new. But you can burn other things and get something new. Like when you burn wood, you get ash. All right. Elements can then combine with each other to form new things like compounds. So hydrogen, we know, is an element, and you should be familiar with oxygen. And when they chemically combine, they form water. So those 2 elements chemically combine to form H2O, dihydrogen. So 2 hydrogens and 1 oxygen. All right, and we get the water molecule. This is a polar covalent bond because it shares electrons. Now, all of this is going to be over your head right now. But I want you to just recognize that everything in the universe is made up of elements. Now, there is something smaller than an element because an element's a whole bunch of what? Atoms. So pretty much atom and element are the same thing, except the atom is the smallest part of an element. So it's like 1 element is an atom. So you have lots of atoms that make up your element. So there are lots and lots and lots and lots and lots of atoms that make up 1 element. So you could say gold is an element. If you can physically see it, we can break that gold down into billions of pieces that are really small that you can't see that are atoms. Atoms are always moving around. So now atoms are made up of 3 different parts. So you look at this model right there, and they're pointing to, well, let's look at it, orbits. So orbit is something that goes around and around and around, and there's electrons, and there's nucleus. So some of these words you should be familiar with. You probably heard of the word nucleus when we talked about cells. So basically what nucleus means is just the center, and it could mean a whole bunch of different things based upon what you are referencing. So in this case, the nucleus of an atom is really specific. It's in the middle of the atom, and it holds specific things. Things are inside of it. The outside of the atom has these electrons. So let's look at our notes. The nucleus is the center of the atom, and that contains most of the mass. Why does it contain most of the mass? Because the only thing that we really measure with mass is protons and neutrons. Protons are part of the nucleus, and so are neutrons. So in the nucleus, there are protons and neutrons. There's a party going on right here. It's in the nucleus. It'll last the whole year. You've got your protons and your neutrons too. There ain't gonna be any electrons for you. Come on now, celebration. We're all partying and we're having a good time. The electrons are negative. They're not allowed in the nucleus. They're not allowed in the nucleus party. Get it? NP. What's in the nucleus? There's a party. The nucleus party. Party going on in the nucleus because there's protons and neutrons. Do you remember from our story? Protons are positive, yay. Neutrons are neutral. So that means your nucleus is positively charged, has protons and neutrons. But why are the electrons not allowed in the nucleus? Because they're negative and they orbit. They circle. They fly around the nucleus. They're never allowed inside. They're constantly moving. They give off energy. They release energy. They absorb energy. They're constantly moving around. They are an integral piece of the atom because they're the only pieces that can move, so they can be traded. They can be given away, and we can add some to the atom. So electrons are really, really, really important, but they're so tiny. The nucleus does not have any electrons. The only thing that's inside the nucleus, party going on right here, party in the nucleus, protons and neutrons. There's no electrons. Oh man, electrons are not allowed. That's why erasure the electron is so negative. He's never allowed in the nucleus. All right, let's review. The atom has three parts: protons, neutrons, and electrons. Where are they found? All right, let's look. All atoms have a number. We give them a number on the periodic table. Go back to the beginning of the periodic table. You see these numbers? H has a number 1. He has a number 2. Lithium has a number 3. They're all tagged with a number. What does that number actually stand for? That number means how many protons are in the nucleus. So each atom has a different number of protons. We call the number in the nucleus, we call the number of protons the atomic number. So the number of protons is called the atomic number. Every atom has a different atomic number. Now, every atom wants to be neutral. And because every atom wants to be neutral, if it has a positive charge in the nucleus, it has to have an equal negative charge. So that means that the protons and the electrons have to be the same. So the atomic number for silver, let's practice. What's the atomic number for silver? Ag is its symbol. The atomic number is right here, 47. So what does that mean? That means that there's 47 protons in the nucleus. So what does that mean? That also means there are 47 electrons because protons are positive, electrons are negative. Together, they have to balance out. So if I have 47 protons, I need 47 electrons. Otherwise, I have something called an ion. All right, and we're going to go over that in more detail tomorrow because we're going to be doing a little computer activity. It probably won't be tomorrow, it'll probably be Monday. All right, so what do we got here? We got these two circles. You have one circle that says P with a 13, one circle that says P with a 20. What does the P mean again? Protons. What do the protons stand for? The atomic number. So if you go to your packet, page 2, in your chemistry packet, go to packet page 2, please, and I want you to tell me what element is number 13. So we have to look for the atomic number 13 because it tells us it has 13 protons. So that means it's going to be number 13 on the periodic table. So go to packet page 2 in your packet and look for it. So what is number 2? Let's see. It's going to be number 13 is Al. And if you look at your packet, Al symbol means aluminum. That means that there are 13 protons in the nucleus. So how many electrons are there? Oh, Miss Samuelson, you told us that the electrons and the protons need to be the same. So there has to be 13 electrons. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Get this out of here. How come I can't say, oh, Miss Samuelson, what did you just do? I tried to move that. All right. There's 13 electrons. Say it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can't see it because this stupid thing is in the way. Can I move it? No, I can't move it. All right, let's look at this one. P20. What does that P mean? P means how many protons in the nucleus. What does the protons tell us? The atomic number. Let's look on the chart. We're looking for number 20, and we see it says what? Ca, which is calcium. That means that calcium is on the periodic table on the left-hand side. It has 20 protons. It also has 20 electrons because the protons need to equal them. But in this case, then it has an N too. It has 20 neutrons. All right. We just did this. Why is my computer going crazy? All right, there's another thing you need to know, atomic mass. So besides atomic number, you need to understand what atomic mass means. I know this is all crazy for you guys. It's a lot to remember. But once you remember this, you'll understand how it works. The total mass of the protons and the neutrons, we said, was in the nucleus. So what's in the nucleus? The party, protons and neutrons. Now we call the nucleus the atomic mass. So that's all of our protons and neutrons combined. We're going to say that protons have a mass of 1 and neutrons have a mass of 1. Electrons are so small, we're going to say they have a mass of 0. But they really have a mass, but it's like 1 over 1840. It's like a really, really, really tiny mass. So we kind of like don't even add it in because it's so tiny. Now, the atomic mass is located on the bottom of your periodic table. So if you look up lithium on the periodic table, our periodic table rounded it to 7. Now, the rounded number is just the most common number because most of the mass is in the nucleus and we don't have pieces. We don't have like 0.941. That's an average number of protons and neutrons, but most of the neutrons and protons most of the time add up to 7. So what does that mean? Well, you know that lithium has how many protons? 3. So if lithium has 3 protons and the atomic mass is 7, there's 3 protons in the nucleus. What's left over? Well, 3 plus blank equals 7. The atomic mass is the protons plus neutrons. We already know that there are 3 protons, so that must mean there are how many neutrons in here? 4. So the atomic mass tells you the number of protons and neutrons, and all you have to do to find the number of neutrons is subtract the atomic number from the atomic mass. What do we think? You think we can practice this and see what we got going on? All right, so with the time left, we're going to do a little bit of practice, and there's a document that is attached, so you guys are going to practice that. All right, thank you.